Hello, everyone. Welcome to Approach to GMAT Questions segment. My name is Joshua Ubuya, a GMAT trainer and coach with the Kenya IELTS program. We'll bring you questions that are from the GMAT exams and show you how you can approach them in both quant and verbal sections. You check out our other videos to find out more. This session will be looking at permutation and combinations, tips and tricks. This is one topic which is normally problematic to students, but once you grasp the concepts and find a few ways of approaching the questions, it can be one area that you can be able to pick some easy marks. Yeah. For you to be able to tackle these questions properly, you need to be very conversant with the topics, the concepts. Yeah, the concepts become paramount. Once you know the concepts, then you need to know how to apply them. And that's what we are here to do. And before you get to seeing the application, there's some formulas which if you get to know them, they can be of good help in saving you time in the exam room, since the exam is timed. For instance, whenever you see anything that is in the form of n combination 2, this can be solved by n times n minus 1 all over 2. Yeah. Whenever you see also n combination r, this is equal to n combination n minus r. Yeah. Whenever you see anything that asks you to arrange identical items from a group, let's say apples, oranges, and bananas, and they are being asked numbers, can you arrange them? Just take the sum of them. That is A plus apples plus oranges plus bananas. Yeah, all of it factorial. Then divide it by apples factorial, by times multiplied by oranges factorial times bananas factorial. These are formulas you need to know. This is the number of ways in which you can arrange groups of identical items. Whenever also you have n combination 1, n combination 1 is always n equals to n. N combination 0 is equal to 1. Yeah. Then 0 factorial is equal to 1. 1 factorial is equal to 1 as well. So getting to know some of these tips and tricks will really help you save on time in the exam room or in exam situation, and also can save you time when it comes to approaching questions without thinking so much through them. So with that being said, let us now dive into the questions. The first question we look at is an easy question. It is actually a question from the easy category. These types of questions don't require much thinking, if I may say, much thinking for it to solve or get the correct answer. It's just more or less applying being able to translate the problem into what is being tested, apply the formula, and you get your answer. In a certain contest, Mark must select 3 of 5 different gifts offered by the sponsor. From how many different combinations of 3 gifts can Mark make his selection? You could pause the video, try this question, then come back and attempt it together, or if you're ready, or you can just do it together. So from this question, we're seeing that Mark has to select 3 from a group of 5. So you have 5 combination 3. That's what you have. So in this one, once you have it this way, just find out in how many different ways can you select 3 items from a group of 5. That's what you're being asked here. And this reduces to 5 factorial divided by 3 factorial times 2 factorial. So that is 5 minus 3, which is 2 factorial. This also reduces to the format that we had seen earlier, where we have actually anything. This is actually it is equal to 5 combination 2 as well, and 5 combination 2 can be solved by 5 times 4 divided by 2, which is equal to 10. Yeah, of course, this is 5 combination 3 is also equal to 5 combination 2. 5 combination 2 is equal to 5 times 4 divided by giving you 10. So 10 becomes the answer. So this is a pretty much straightforward question, and it's an easy one, and you may not see it in a high difficulty kind of question. If you're seeing it, you're more or less still tackling easy questions in this topic, and should be an easier way to help you breeze through to the higher difficulty questions. Now, when it gets a bit tougher, just asking you a different variation or formulas which will not be so outrightly available, or just a bit of reasoning, not really putting so much thought to the question for you to get an answer. Let's take a look at this question. The florist is planning is planting flowers for the spring flower show. He is trying to decide how to place 3 tulips, 3 daffodils, and 3 crocus along the front row. How many different arrangements can he make of these flowers in the front row? That's what we've been asked. So we have 3 tulips, then we have 3 daffodils, and 3 crocus. Yeah. And we also arrange them in the front row. You see, we have groups of identical items and we're being asked to arrange them. So actually, this actually reduces to a formula also, which I had seen earlier. And this can be sort of the question 3 plus 3 plus 3 comes to 9 factorial. Divide by 3 factorial times 3 factorial times 3 factorial. Times 3 factorial. Yeah. This reduces to 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial. I normally leave out the last factorial out because it will cancel out with one of the denominators. So the smaller one or the larger one. The largest denominator normally I leave the largest factorial from the denominator. I leave it out because it will cancel out the numerator. It's a tip I use for saving me on time as well. So this will give you 3 times 2 times 3 times 2 times 3 factorial, which will cancel out. And this is 6, will cancel out with 6. 2 will reduce 4 with 2. Then 3 can actually go with into 9 3 times. So we left with 3 times 8 times 7 times 5 times 2. Yeah. So this gives us which one, how can we multiply them in a way that will make it easier for us? So 8 times 7 is 56. 56 times 3 times 10, because 5 times 2 is 10. So it's 18 rather. 6 times 3 is 18. 31. 5 times 3 is 15 plus 1 is 16, then 0. So 1680 is the number of ways in which these flowers can be arranged in a row. So that becomes choice number E, choice E. Yeah. So this type of question, they still also require, these are formulas which are not so common, but then again, they're still, knowing them is very vital because it's just applying the formula as it is and a bit of reasoning, and you have your answer. Let's look at another question, the same category as well. Mikey has 10 different letters and 5 different envelopes with him. If he can only put 1 letter in an envelope, in how many ways can the letters be put in the envelopes? This is a bit tricky. You can pause the video there and come back and we attempt it together. He has 10 letters, 10L, and he has 5 envelopes. So a letter can go into only 1 envelope. So which means at any given time, Mikey can only actually use 5 letters from a group of 10. So he can only pick 5 letters from a group of 10. And then, if actually asked how many ways he can put the letters in an envelope, just being asked in how many ways will he actually leave some out and then put them again and circulate that circle over and over again. So the first thing we need to know is actually in how many ways can he select 5 letters out of the 10 letters. That becomes 10 combination of 5. Once he does that one, he can do this 5 times. Yeah. Once he does this 5 times, that would give him not really just one way, but a certain number of ways which he can do that. But that's not all. Still, actually, he leaves 1 letter out and remains actually 9 letters which he can select from. Then again, after he selects again 5, he'll actually be left with 4, which also he can select from. So he may do that 4 times. So you'll end up doing this and now seeing a pattern of having 5, then 4, then again, if he leaves out 2, remaining 3, then 2, then 1. This ends up being like a factorial of 5. Yeah. The number of ways, the letters that are left behind, this shows the number of circulations that the letters can be made into for them to be exhaustively used. And actually they still remain more or less like unique combinations. So this is what you end up with. So such questions normally, it requires a bit of reasoning and it requires quite some thinking to put into it. Because the thing first you have to think of the number of letters that you have, and what can you do? What is the limitation? The limitation shows how many ways you can pick out something, and then again you combine it with the factorial aspect, which is permutation, and that will actually come 10 combination 5 times 5 factorial, which is choice C. So whenever you see any questions that do have a limitation and they ask you, then they left in some left behind, and they can be swapped into the combination again, then actually that means that you need to use a factorial. That. Yeah, I hope that is clear.
You're watching Success with Bob Mwiti Show, presented to you by Appstech America. Appstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.appstechamerica.com. Appstech America will wake you up to the unlimited potential within you.
Let's look at the next question. This is now a 700 level difficult question. These types of questions, they're not very difficult. Let me say so. They're not very difficult. What happens is they have a combination of multiple concepts, and they require a bit of reasoning to be able to get to the answer. Yeah. So let's attempt this one and see. There are 27 different 3-digit integers that can be formed using only the digits 1, 2, and 3. If all 27 of the integers were listed, what would their sum be? Yeah. So this question doesn't ask you actually to list down these numbers. It has told us that you have the numbers 1, 2, and 3. Yeah. Just for your own challenge, you could post a video attempt. Otherwise, let's just proceed. Yeah. So they have 1, 2, and 3. All the number of ways that they can be listed, yeah, for a 3-digit integer, they're actually 27. That's what we've been told. And then now we're being asked to find what their sum would be. So this is more or less a counting methods question, and it has multiple approaches. We could just look at maybe 2. Some of them are not actually. Some of them also you could look at them, but they could be more tedious. Yeah. The simplest one which I found is that if you look at these questions logically, if you have 1, 2, and 3, and then you have all the variations you have are actually 27, and at the same time we're being asked to sum them, it looks like a counting methods question, but at the same time also it looks like a sets question. Yeah. If you look at the sets, the number of sets you can get is n times the average. Yeah, this gives you the sum. Yeah. The number of elements times the average value of the elements gives you the sum, or just adding all of them together. This is the basic concept that you may have that could be applicable to this. The thing you need to take note of is actually how these numbers are formed. So you have the n times the average give us the sum, and then you have n being 27 times an average, let's say x is equal to the sum. So you need to find what this x would be, that is the average, for us to be able to get what the sum will be. If you get that one, then we are home and dry. So one thing we need to take note of is how these numbers also formed. Remember, we're being told that there are a 3-digit integer. So a 3-digit integer will have, let's say, those 3 positions, yeah, of which the first position, the hundreds digit, can take how many values? It can take 3 different values, because it's 1, 2, and 3. The second position, the tens placeholder, can also take in 3 positions, because you're not being told that they're unique, because actually that or none cannot repeat itself. So it can be then 3 different ways. And the units digits also 3. Yeah. So if you multiply this, you get 27. Yeah, that is how these digits are formed. So what this means is that we do have actually 1, 2, 3, 2, 3, 1, 2, 2, 1, 2, 2, 2, so on and so forth. If you write all these down, you'll actually end up having 27 different variations of the number 1, 2, 3. That's what it means. For you to get the average, that means that all through from 1 all the way to 27th value, if you were to sum them up and divide them by 27, what will you get? Yeah. Since you only have 3 digits that will be here, they'll appear in the very same way. And the average of 3 digits will still equal to the average of what you have for those. Yeah. So the average of 1, 2, and 3 is what? Actually, that will be 1 plus 2 plus 3 divided by 3. It will be equal to 2. So the first position will have an average of 2. Second position have an average of 2. Third position have an average of 2. Because to be the same value all through. They're appearing in exactly the same way. So the average of these 27 digits will end up being 222 times 27 will give us the sum. If you multiply this, what do you get? Yeah. So this will actually give you, if you multiply it, it will give you let's see. Let's just try it out. 2 times 7 is 14. Carry 1. Then 14 carry 1, that is 5. 5 for the last digits. We have 54 here. No. So then again, 2 times 7 is 14 plus 1 is 15. So that is one that you have. Then this one times 2 will be 4. 4. 4. Yeah. So 4, 9, 9, 5. And 5. So 5,994, which is just E. Yeah, if you multiply them, those two, these values, that's what you get. So this is actually the sum of all the digits. This is one way of approaching it. Yeah. Another way of approaching it also would be, as you can see now that you have, this is the sum. Let's get rid of these ones too. Looking at it also could be actually just by understanding and logically thinking through the placeholder values and just trying to sum them up and see. Yeah. For instance, if actually we do have it this way, we'll have 1, 2, and 3. Check these positions 27 times. Yeah. Again, the other one again 27 times, not 27 times, but 9 times. Another way of looking at it is by looking at the placeholder values and how many times each digit repeats itself in those placeholder values. Yeah. Because actually we do have actually 1, 2, and 3 digits on these places. These placeholder values will show the number of ways in which the digits will repeat itself. Yeah. We have 27 variations. 27 variations. Out of those variations, we only have 3 digits. That means that each digit repeats itself in 27 divided by 3 times. That is 9 times. Yeah. It means each digit repeats itself 9 times in those 27 variations. Yeah. So we need to find out in how many ways will you have these digits appear, the units digits, the hundreds digits, the tens digits, the hundreds digits. Then we sum them up and be able to get our answer. So since actually it will, for the units digits, we'll have 9 times 1 plus 2 plus 3. That will give us 54. Yeah. Again, in the tens placeholder, we'll have 9 times 1 plus 2 plus 3. Then this will give us 54. Yeah. But how do we sum them? We don't just sum them like we would do in another place. Since this actually, the 4 will not actually, since we have it now in this way, let's see. We have 54 as the sum of digits that we do have. But for the next digit of the tens placeholder, it doesn't need to go to the units placeholder. Still actually come to 54 there. So if you add these ones, you'll get 4, you'll get 9. Then actually, yeah, that is it. Then at the same time, also hundreds will also go have 5 and then 9 below it. But don't need to go all the way. Just by these two alone will actually give us the last 2 digits of what the answer is. And you can just pick it from the answer choices, look for whatever has 94 in it, and that is choice E as the answer. If you want to go all the way, well and good, but for the sake of saving time, you don't need to go all the way. Yeah, that is the second option. So these are the two main options that you may use to solve such a question. And should you have any other questions or even just comments or even ways of approaching such questions, just feel free to post them in the comment box below this video. If you like this video, go ahead and feel free to share with your friends. Like the channel, come back again and see more questions. See also questions from other topics and be GMATized. Yeah. Apart from that, also, you can feel free to join our training program if you try to learn the tips and tricks and ways of being able to prepare effectively for the GMAT exam and getting a good score. See you next time. It was good having you. Bye.